Right, good morning, everybody. Welcome to our design simulation and metrology special interest group event. Should be a really interesting event for you today. My name is Pim van Baars and I'm CEO of the Silverstone Technology Cluster. I won't be your compare today because we have Paul Kirkham, who's one of the champions for the design simulation and metrology group, who will look after us. As per usual, we're recording this and we'll share the recording with you afterwards. We'll also share the slides of the speakers with you all afterwards as well. So, you know, if you did want to follow up with anything or relive any of the presentations that you can, so we'll send all of that over to you in a moment. But with that, I think I'll now hand over to Paul to guide us through the day. So over to you, Paul, and good morning and good luck.
Excellent morning, Pim, and yeah, thank you very much. So yeah, on behalf of myself and the entire champion group from the DSM SIG, welcome to the event, and thank you for giving up your time to attend. As Pim says, my name's Paul Kirkham. I'm key account manager with Altair, and I look after Altair's automotive and motorsport clients, many of whom are clustered around the Silverstone area. So a little bit about the design simulation and metrology SIG. As with all those special interest groups, I guess really the aim is to bring together a variety of experts from those different fields, really to try and inspire, inform, and evaluate latest developments, capabilities and processes, and really try and provoke the discussion and awareness in those fields, and increase collaboration across our businesses. And this event came about as a result of one of our regular meetings of those DSM SIG champions. And we're all very used to meeting for a coffee at one of our offices, but obviously, like everyone at the moment, this was a Zoom meeting that we were having. And as is the way, rather than sitting there discussing the agenda item, which was suitable topics for the next event, we realized that we were spending a huge amount of time really sort of just chatting away about the impact of COVID and the pandemic and the effect that it had on our businesses, the changes we had to make, and sort of the challenges, how we were overcoming them, and the opportunities that it was presenting. And I guess after a short while, we realised that actually we'd stumbled across a really interesting and thought-provoking topic for our next event. So hopefully, what we've got for you today is a series of lessons learned, opportunities, and experiences from some of the thought leaders from our different companies in this field. So really, as we approach the end of 2020, and I guess it's been one of the most challenging years for many businesses and individuals, it seems quite fitting that also on the day that the first UK COVID vaccination is administered just down the road in Coventry, it's a real pleasure to be welcoming you to this event on post-pandemic, the route ahead. So over the next couple of hours, really, we've got three fascinating presentations looking at how the pandemic has shaped those businesses and will continue to shape businesses and industry as we move forward. And after each presentation, there'll be a short Q&A session. So please get involved. We put these events on for you, for the delegates. So please take the opportunity to get involved with the Q&A. And then we'll be concluding the session with a roundtable debate. So please make sure you hang around for that one, and again get involved where appropriate. So enough of me rambling on. Without further ado, I think we should kickstart with the presentations for the day. And first up, I'd like to introduce Royston Jones, a colleague of mine at Altair, who is going to give us a presentation on harnessing the full potential of simulation. Over to Royston.
Good morning. My name is Royston Jones. I look after Altair's UK operation. I'm also the CTO of Altair's global consultancy business. The reason why I mention that is it gives us an opportunity to visit many of our clients, or certainly did do before the pandemic, and help them with their simulation sort of strategies. So I think I observe from the field and draw many of my conclusions from the field. You'll now see a talk that I gave early October for the Altair Global Conference, and I think this talk encapsulates many of the thoughts that I had around the time with the pandemic. It's a fantastic venue, the Royal Institution, and you can see why we decided to repeat that particular talk. Okay, well, enjoy the talk.
Hi, my name's Royston Jones. I'd like to briefly introduce myself. I started many years ago my academic career at Swansea University. I did my undergraduate and then I did a postgraduate degree at Swansea University. During my time as a postgraduate, I was lucky enough to work with some of the founders of the finite element method, Professor Sienkiewicz, Professor Hinton, Professor Owen, and it was a very interesting place to work. It was a civil engineering department. It had nearly 100 postgraduate students, and all of them did simulation. If you were doing experimental testing, you're effectively ostracized, which I like because I'm hardcore digital. So following that passion for sort of simulation, eventually, after a few twists and turns, I ended up at Altair. And I've been at Altair now for 22 years. Altair's been a great home for me. It's a company that has simulation as part of its sort of DNA. I'm the sort of CTO of the consultancy business unit, which gives me the luxury of actually interacting a lot with our clients. So I'm out in the field a lot, sensing their requirements and seeing and promoting how simulation can help them. We're here today at this fantastic lecture theatre here at the Royal Institute, which is a promoter of science education and research, founded in 1799. In this spot, nearly 200 years ago, Michael Faraday, who was the director of the Institute's laboratory, started Friday evening discourses and Christmas lectures. And to this day in the UK, we still televise them Christmas lectures. His leading discoveries were around electromagnetic rotation, which basically form the principles of the electric motor, and also electrolysis, which basically formed the science of battery technology as we know it today. It was Faraday who coined the terms of anode and cathode and electrode and ions, which obviously are all the fundamentals of battery technology. I think today he would be amazed that the next generation of products that we're looking to create, which have been electrified, rely so heavily on his fundamental discoveries, the motor and battery technology. So I'm here today to talk about something which, since the pandemic and visiting clients, has been quite a big mantra, which is, how do we achieve more for less? So if we look at more for less, and in the context of product development, I think we see that more for less means leaner teams, and consequently, it's a technology solution which needs to be utilized. And engineering simulation is the key to satisfying this particular requirement. The global pandemic represents an opportunity for companies to disrupt. It's time to stop operating at the margins and embrace a stronger vision for simulation. So let's look at the historical evolution of simulation within industry. And we see that for nearly 4 decades, simulation has been used in the field of verification, where by reducing physical testing, it's been able to reduce costs. So the predictive capabilities of simulation as a verification tool have grown, fueled by the power of high-performance computing. If we see the evolution of simulation in design, we see at the turn of the century, we see momentum gathering. And here I think we see 2 key areas on the power of simulation gaining momentum. One is speed. Speed is key. If you can't deliver your results to a design process in the allotted time, the design has moved on. So speed is absolutely key. And the other is innovation. Through innovative technologies such as optimization and more recently machine learning and artificial intelligence, these technologies are adding and injecting innovation into the design process. So I've got a small little example here about how design, where when you look at design and a designer, where the geometric asset and the geometry is everything, how technologies like optimization were starting to contribute to defining what that geometry is. So here you see a simple sort of crush bracket. If you're ever in a car and you get unfortunate enough to have a crash, then essentially your knee will impact a fascia, which will then start to crush this sort of bracket. So it's an energy absorption device. So here what we did, we basically allowed the computer to select and combine from a variety of shapes and basically tell us what that optimum geometry should be to deliver the perfect crash characteristics. So this process was actually developed nearly 20 years ago and replaced an iterative engineering process where you gather a file very, very thick. And this process is still used now at Jaguar Land Rover. I think my other observation in this process was around about 2009, where we had a fuel crisis shortly followed by a financial crisis. And here technologies such as optimization were perfect to control weight, proactively controlling weight and balancing the performance against weight. Is a perfect tool, and we saw acceleration of adoption then. I think this crisis that we're currently in, this pandemic, I think that will also see a further increase in the adoption of simulation. Let me briefly talk about another driver, creating the next generation of smart connected products. So what defines a smart connected product? Well, firstly, the hardware is more multi-physics. It not only has mechanical attributes, but now maybe it's powered by an electric powertrain. So basically, it's more about creating electric product driven by a green agenda. Also, everything is connected with Wi-Fi, piping information to a cloud, or with inside the product itself, connecting to various other areas, through DAB, through GPS, a massive amount of connectivity. Sensors everywhere. In modern vehicles now, you're approaching upwards and continuing to approach nearly 100 sensors in these vehicles, generating a massive amount of data. Data either being used internally within the device at an ECU or being piped up to the cloud. With vast amounts of data, and consequently the requirement for data analytics. So when you start profiling these companies, we see them changing. We see them less about mechanical, more about mechatronic. We see the way that they're advertising for engineers out in industry, more about software development, more about data science. So within an engineering wing now, you're seeing leaders in data architectures, because it's how we start to use this sort of data. So what you start seeing is this convergence between simulation, between high performance computing and data analytics. These three areas are more start to converge in a product development sort of cycle. So within these structures now, which are more mechatronic in nature, where basically you have more software in the control system interacting with the mechanical system, this is the way that this technology will go. So when you look at this concept of digital twins in the context of a mechatronic device, I think what we want to introduce is this intelligent digital twin. So what I mean by that, if you look at the parallels with the human body, you see the body itself, you see the brain, you see the nervous system. The parallels for me in a mechatronic system is essentially the body is the hardware, the brain is a computer, many computers, and then the nervous system is these sensors, this information where you're piping this high volume of data through your veins, or in this case, to the hardware or to the cloud. But it's not enough just to optimize a mechanical system anymore. It needs more of a holistic view of actually optimizing the complete system. So I have this little device here, which is an underwater drone. It was part of a Shell X Prize, which is all about going down nearly 4 kilometers and performing seabed surveys. So this little fella, this is the physical component, was deployed, and it hovers above the seabed, gathers information, comes back to the surface and starts piping information to the actual cloud. So this is an ideal mechatronic example, and we created his digital brother. And in order to do that, we had to integrate all of the control system into our simulation of the actual hardware itself. So we could look at how it would deform underneath the hydrodynamic loading, and then how it would react. So one thing then, you get this synergy between the physical and the digital, and they help teach one another to swim. The other thing, that this was pioneered by a very small team, less than 10 people, do more with less. And it's great for going into the unknown, which is another great benefit of simulation. In these smart connected devices, you no longer have an evolution history that you can call upon. It's very rare on occasions that you've got a solid reference design that you've developed over a long period that you can actually call upon. So going into the unknown, simulation is really key. So let me just discuss one final example, which I think promotes a lot of the discussion items that I've raised here today. And this is to do with the development of body-in-white structures, which once again are becoming increasingly smart because they've got electric powertrains. They will have a battery system sort of buried within them. So I think from my perspective, historically, when we looked at this area of sort of concept sort of development, we saw that simulation was still being used as a verification tool, which for us was crazy, because in the area of concept, where you want to experiment the most in order to inject innovation, simulation, as I mentioned before, in design, is a really key technology. So nearly a decade ago, we started to pioneer processes that basically would allow us to deliver in the timescales that an aggressive design environment required design input using simulation technology. One of our key OEMs has been using this process now for nearly well, has been using it for over 7 years and has used it to develop world-beating product, and we're very proud of that. But I think if we look at some of the key things relating to this sort of process, and the way I know that it's working is when I see great interaction with the design team. And when I see great interaction with the design teams, I know that they're engaged. And we have that engineering collaboration. So, and the designer is more hungry for the data that he's receiving. So once again, it's about speed. It's about being able to deliver really quickly and address some of the issues that the design team currently has, make sure that you're aligned to the project milestones. And then I guess it's this innovation. And once again, optimization is perfect here because it allows the packaging to be explored, which delivers innovation, but also looking at this balance all the time between minimum mass and the trade-off between performance. So allowing this dynamic between the engineer and the actual designer. Last year, we actually did a project for Jaguar Land Rover. It was a proof of concept project. And there the challenge was to optimize a body in white structure in a day. And we did quite a lot of preparation work. We identified where there was some technology gaps. So leading into this one-day challenge, it's fair to say for quite a few weeks, we basically did our homework. We made sure that the data would work well with our technology. So we went into the challenge with a high degree of confidence. There was basically 2 people. One was going to look after the crash, and the other one was going to look after the noise and vibration. So they commenced that process. There's a vast amount of detail. We started with a high fidelity model, which they gave us, because once again, you know, a high fidelity model need to be converted to a low fidelity model as part of the process that we developed. So it's not a natural starting point in this process, but it's a confidence builder with our clients. So we converted to a low fidelity model. We did a lot of verification to make sure that this model was giving great design direction, and then we optimized. And on the second day, you can then start doing your design variation solutions. So a lot of people will say, you know, okay, you know, you did a lot of prep work, you knew it was going to happen in a day, you know, but one day soon we will be able to do it in one day, because ultimately we keep on enhancing that technology, and the power of this technology will only get better and better. It will fundamentally change the way that we are designing products. So in my summary, what I'd like to say is that we see simulation basically gaining momentum within industry. We believe that this pandemic will further accelerate the use of simulation in design. But for me, it is the answer to do more with less. I think from my own personal experience, I still see industries using simulation too much as a verification tool. So they need to unlock the potential of simulation, which is already sitting within their company. They need to unlock it for design and reap the benefits that I mentioned throughout this sort of talk. I think the move to create these next generation products also mean that the adoption of simulation is imperative. If you're going into the unknown, or you want to even reduce costs because you're a startup company and you don't want to pay for expensive testing, then simulation is that key. So for me, it's time to stop operating in the margins and embrace the power that simulation can actually deliver.
Well, okay, I really hope you enjoyed that. That 18 minutes sort of flew by. When I reflect on it, I think there's quite a lot of content in there. Now and again, it's quite dense with content, but I think just to summarize, I think some of the key themes for me was First of all, I think just the importance, particularly during the pandemic, of simulation. Obviously, both testing, physical testing, and simulation go sort of hand in hand. And I feel particularly when a lot of the labs during the pandemic no longer had access, that I think once again it just demonstrated the power of simulation. And I'm hoping that we can move away a little bit more from a testing culture to have one which is using these both test and simulation more in tandem. I think the pandemic will help do that. I guess the other key point was the use of simulation increasingly in design, and I think the future of design is having simulation at the heart of a design process, using technologies like optimization and machine learning, etc. Hopefully we sort of made that point, and I think undoubtedly we'll continue along that path fairly aggressively post this pandemic. And I think the points you made there, particularly about the next generation smart products, will only emphasize that. I guess the other thing is about communication, and the way that a lot of these companies, design companies, the OEMs have kept on going. You know, innovation is obviously, you have a collaborative environment, but I think through the digital technologies like Teams, etc., then design processes have still contained their momentum. I think a key thing is, quality of an engineer is communication, and I think at Altair we're always looking to communicate the results of our engineering in very innovative ways. And I think that you see the example here about this is quite a complex multidisciplinary optimization, and here we're trying to give new results displays on how to communicate. And I think that trend again will continue. And certainly during the pandemic, being able to communicate effectively our engineering results has been even more important, where we can't all huddle around a whiteboard. So yeah, I'm hoping you found that really interesting, and thank you for your time. I really appreciate it, and a really big thanks to the organizer, the Silverstone Technology Cluster, for this opportunity to present some of these ideas. And if you want to learn more, then I'm sure you can find me. Okay, all right. Thank you. Bye-bye.
Wonderful stuff. Thank you very much, Royston, for fascinating presentation. I hope everyone is in agreement. Do we have any questions from the delegates for Royston?
I'm quite happy to kick in with a question, if I may.
Yeah, please, Ben.
The one thing that kind of always amazes me is because I've seen some presentations from Rolls-Royce as well on digital twinning of their engine, so they can predict when they need to apply maintenance and all that sort of stuff. And it's kind of like the real world correlation always fascinates me. It's like, how do you know? And presumably a lot of that has come from you simulate it and then you test it in real life as well to make sure that your simulation was accurate and stuff. At what point, and I don't know whether we're there now already or not, are we ever at a point where we're going to do away with the physical testing for the correlation and we're just going to go with simulation because we know it's so accurate that it's just going to be fine? Is that already happening? Are we there yet? Or if we're not there yet, will we ever get there? And if so, how soon? Or is this an impossible question? I don't know.
Oh, it's a great question.
Yeah, I think in some areas you can homologate your product via simulation alone, but I guess that's after building up quite a successful correlation history. I think particularly if you look at the car industry, which is obviously
driven simulation hard for many decades, they've considerably reduced the amount of testing that they have to do, because obviously they made that investment in making sure that their simulation is highly predictive, which I think, in general now, getting a 5-star crash car, providing you have the money to buy all the safety kit is quite easily achieved these days. It's more about the noise and vibration. I think one thing throughout my career, the thing which I've always found a little bit of a frustration is that, the experiment is gospel. The physical experiment is gospel, and the simulation always has to chase it. Where in reality, the experiment itself is also susceptible to noise. And I think that that's why now and again the repeatability of experiments are also checked. And in the same way as you have the noise in your experiment, you can build noise into your simulation, and consequently, I always feel it's more of a correlation when you start including the noise. And I think in future that's the way it will go. I've been at tests whereby they've done a test and all of a sudden they pointed the finger at the simulation and said, why aren't you agreeing? And then you get the physical article and you find out that maybe some of the welds have been poorly managed in the prototype, and where you thought there was a weld, there actually isn't a weld. And that's the noise that can be seen in the physical reality. So yeah, I'm not too sure I answered your question, but
I think it's a great point, and I think obviously a testing is equally a one-off event, and you have to increase that test sample to get a reasonable spread of the real world events as well. And when you look at you're testing products that are being mass manufactured in the hundreds of thousands, the millions off, that are then out in the field being used in all sorts of different ways, and trying to pass those with a single instance of a test. So in some respects the simulation world can cover that variety of spread much easier, particularly with the increase of availability of HPC. We have another question from Trevor. Trevor, please go ahead.
Sorry, my ID was my university ID, which was rather bizarre. I've just changed it. We've had a number of situations where, I work in metrology, so we've had a number of situations where we simulate most of the things we do. In fact, we simulate all our measurement processes as well, because if we don't fully understand the capability of those, then the rest of it becomes a little bit pointless, really. So we took a fuel tank where we were asked by a premier car manufacturer to reduce the weight of that and optimize its strength at the same time. So we did the usual modeling, which was very good. We then took the measurement process and we modeled the measurement process a little bit longhand initially. And then what we did is we took it on to, I see David Brown's here, one of his CMMs, and we modeled the uncertainties on that as well. So we had all the probabilities so we could understand those without getting all mathematical. What we found was the original simulation was not what we'd predicted. So we predicted what the measurement system should do. Then we looked at all those uncertainties, and what we found was an almost perfect correlation. And we, in the usual way that you do things, we nudge one variable at a time, firstly in the simulation, then in the real world. And we found we had absolutely superb correlation throughout the whole process. And as a result, we could optimize we did optimize the fuel tank and went way beyond the weight loss that they'd asked for. So I think, will we ever get to the stage where we don't have to measure things anymore, we can just simulate? I think it's a little bit away, but that's all down to how confident are you in your processes. So good processes produce good parts and good services. So if you have a degree of confidence with your measurement and your simulation within your processes, then there's a perfectly sensible and rational argument that says you don't need to measure things anymore. Whether I'd want to run a plant that does that, I'm not sure. I will always want to measure, but we measure for verification, to validate what we already know, as opposed to measure to find out what's going on. The simulation is what tells us what's going on in terms of probabilities. The measurement validates what we already know. They're my thoughts, and have been for a long time. How close we are to that,
absolutely,
I don't know. So.
No, I think you've hit the nail on the head there very well, and it's great to hear, you know, another experience of that process happening. You know, and I think obviously the great thing with simulation is it can really help the innovation. So, you know, nothing is standing still. There's always new materials, new manufacturing methods, new constraints, and consumer desires coming into play. So we're always pushing innovation, and as a result, we then have to continue that correlation approach, because yes, we've built up this fantastic history of verification, but only verifying processes and materials and manufacturing methods to date. So as we continue to find new ones and explore and make the most of those, we have to continue this relationship between simulation and test. So we can definitely use the simulation to explore and optimize, but yeah, there will have to always be that reliance on some element of generating the inputs to that via those testing. So yeah, great thoughts.
I really like the comparison to the human body with you know, the brain, the nervous system. You know, that I thought that comparison was really good. I wish I'd have thought of it.
Absolutely.
And if you look at that, and you look at, you know, good processes produce good parts and good services, because it's not all just about manufacturing, then if you look at the digital twin being a real-time reality, you know, in terms of, you know, the human body, your nervous system that informs your brain without us necessarily being aware of it going on, it's all going on in the background. So this intelligent, or the AI within that system, integrated into your sensors, and having that full traceability in real time, gives the system the ability to make the decisions based on simple or sometimes not so simple algorithms within your system. Then you are at a point where you say, well, I don't have to measure. Or some would argue, I don't think we'll ever be at the point where we don't have to measure, because actually the measurement is all now taking place within the process, within the system. The measurement is your process. It's not something we think of separately. It's built in. We don't think of electricity as something separate, but without it we can't do things. So metrology will become that hidden machine, that hidden brain, that hidden nervous system that keeps the brain informed. I think that's the way forward, and that then allows the brain to make the right decisions in real time, as indeed we do. Well, sometimes
absolutely.
We make the right decisions anyway.
And as you say, we're seeing that already, aren't we, with Venisure and their additive manufacturing machines, where they're integrating that actually into the process. So now, you know, as these machines are manufacturing directly, you know, lasering the powders, they're measuring as they go. So yeah, these things are becoming very, very interconnected. Yeah. Great stuff. Any other questions for Royston before we move on? Okay, in which case, sorry.
Hi, Paul.
Yeah, go ahead, David.
For Royston, really. Look, I tell you what, that's been a fascinating insight and some real discussion there, good discussion. If I could just maybe put Royston on the spot a little bit here, just to bring it into context around this strange environment we've lived in for the past 9 months. If you were to check, we know that the adoption of simulation and that virtual simulation world probably had a graph or a projection over 5 years that you could sort of see it. I'd be interested to get Royston's view of how the pandemic has probably pushed that curve forward, you know, and by how much has it taken a 5-year window and squeezed it to 4? I just wanted to get that sense, I think, because this year has been a virtual world for us all. So I guess it's a sense of what has the pandemic had on the trajectory of adoption?
That's a really tough question, that one, David, I can tell you. I mean, I must admit, I mean, I'm getting a bit towards the end of my career, I think it's fair to say. And I think in 2001, we did a optimization of the Airbus A380 droop nose ribs, and we took a massive amount of mass out of them ribs. And I felt undoubtedly the aerospace industry will now use topology optimization. It's the tool, you know, and it took nearly sort of a decade to get that technology as part of a process, even though we had that great success. So undoubtedly, you know, there's a lot of inertia in established design processes to adopt new technology. But I must admit, we're entering an environment now where everything is sort of digital, and we see it in our everyday lives. We see, you know, a lot of data, and I feel that the pandemic has obviously accelerated that. So, yeah, I think it will hopefully accelerate it a lot more. So, you know, if you want my, I think it's probably increased it by ×2, huh? Because I think the other thing undoubtedly is that we are going to go into recession now, and I think simulation is a great way of doing that, doing more with less. And I think you know, I think it will accelerate it. I'm sure this time.
Good. Thanks, Royston.
Yeah, thank you, Royston, and thank you, David.
Thank you. Thank you all for your time. Thank you.
And the mention there of that digital process segues us very nicely into our next presentation, which is from Hendrik Schafstall of Hexagon, who has a presentation on the influence of COVID-19 to accelerate the digital transformation for smart manufacturing in particular. David, over to you. Sorry, David. Hendrik, over to you.
Yeah, I wait for some comments from David. So first of all, welcome here. It's a pleasure for me to present in the next 23 minutes the presentation, and I want to build the bridge between simulation and metrology, because we cannot live only with one of the pieces. So let's share my screen, and I hope it will work. So I have not the possibility to stay in a nice theater, so I will use more slides. So I want to explain you what has influenced, I would say, the overall activities and acting from Hexagon Smart Manufacturing regarding the COVID-19. And this especially in the area of digital transformation for smart manufacturing. What is smart manufacturing? So smart manufacturing are the solution to design the right product with the right manufacturing processes at concept, then orchestra perfect quality and minimal waste production by learning and adapting quickly to changing conditions in real time. So what this shows a little bit, this is beyond the design. If we have fixed the design, we have to make sure we can produce it with the expected quality. And we have a lot of uncertainties. We have internal, external noise in the production processes. So there are a lot of things which we only can predict if we use metrology inspection at the end. But this still need to be linked closely with a simulation. Because in a simulation, we have the possibility to capture a big range of variations. So we can use this to understand better what is influencing our quality, what we are measuring at the end. And this comes out in a discussion before. Measurement is only proving the quality, but it's necessary. So what we are doing within Hexagon Manufacturing Intelligence is that we are connecting our different disciplines. Design and engineering, this is the whole virtual area, the simulation area. The production area where we are developing the production process, how we can achieve the quality in the time for minimizing the cost and to create robust processes. Then at the end, we need to measure it and define the quality, and we have a lot of variations and influences, so we have to identify this. And a very important topic is digital transformation. So I will go deeply into this point to connect product development, equipment, and measurement, leveraging the data to increase productivity and guarantee product quality. And what this means is, normally in the life cycle, we have a lot of silos, and we need to connect the silos, and we have to reuse the knowledge, and we have to combine it. So if we are looking to a survey, which we have done before the COVID, what are the companies expecting from Industrial 4.0? It's first compiling and leveraging data to obtain insight in design and manufacturing challenges that impact quality and productivity, and this at the end means costs. On the other hand, they are looking more for integrated systems to combine the engineering and the shop floor, the production, the manufacturing processes, to provide method that can help to take decisions. And here also simulation plays a key role. And third is, and this was even popped up more in the COVID time, is that now when they are investing in Industrial 4.0, they are looking more for the return on invest. That they, when they implement such kind of solutions, that they can fix the problem of today, that they can save money, and that it is sustainable, so that it's ramped up for the future as well. If not, they will get not the money. And this is changed from last year to this year dramatically. Before they said, oh, we have to go this, but they don't know how and with what. So they spend a lot of money. Now they are really more concentrating on do it stepwise, solving first the main pain point and then extend it more and more and more, but sustainable. Now let's have a look to a study which were published from PwC, Accelerate Digital Transformation Post-COVID-19. So this is a different view which are influenced from the COVID time. And the target is here at the end, we want to come through the crisis stronger than before. And they identified 5 key strategic priorities. So first of all, they are looking more for the cost structure, and they want to sharpen the productivity. They want to control it, and they want to minimize the cost. How can they achieve it? Less physical activities, more digital. Supercharge digital transformation to create a digital enterprise. So this means they have to look more for digital twins and digital enabled processes. So even here, simulation is getting more and more important, as already was discussed before. Carve out new revenue streams. We need to be more flexible. So they have to look, if the situation are changing, how can they use the skills, the machine, the knowledge. So they need to find ways to increase R&D in new product development or make it possible to react very, very fast. And this means they need to have clean workflows, clean structures, and even use the experts also in a different field. And this is also an important topic, that we will have less and less experts in the future, and they are depending on this. And even COVID has shown, if they will not be available, then the whole process will stop. So that's why they want to invest much more to automate everything, to store the knowledge, to keep the knowledge, and by using AI, machine learning, and so on, that this they really can extract automatically. The fourth topic is prepare your workforce, training, adopting new tools, and so on, and strengthen the capital efficiency. So even here, the money is not anymore lying on the table. They are really looking for everything, and even this are influencing the way of addressing the things more and more ROI based. So offer them what they need urgently to solve the problem, increase the quality, productivity, and reduce the cost at the end. And reinvention and differentiation. So Hexagon is also thinking in this area and looking what we can offer as a partner for the industry to be part of the journey and to accelerate the implementation of this, of solutions to solve the problems. And why we are doing it. If we are looking to the traditional model where we are, it needs a long time now to really have a big impact to the productivity when we are doing the things as before. And this is what Altair also mentioned before. We need to make the things intelligent. We need to connect it. And we are talking here about a smart manufacturing solution to increase the productivity. And so on, I must move this. So, yeah, and the other topic is also flexibility, fast reaction, and store the knowledge, which are driving the overall process, and we have to make sure to do it. And I want to focus on three main topics. It's collaborate engineering systems, industrial IoT, and the digital transformation of the operation. When you are thinking that everybody has already the whole process in a digital format with connected worker, with clear workflows and so on, it's not the case. Only a few companies are still on a very high level here. A lot of them are still using papers, Excel sheets, and so on. And here it's a high opportunity with a less effort to improve the overall process, get traceability, and transparency of the whole process. And then we heard a lot about digital twins, digital thread. The key is now that we need to link, connect the design and engineering with the simulation part. Then we are going in the prototyping area into the production. And at the end, we have the inspection. All of this information we have to bring together. We have to define feedback loops. And we have to store the knowledge by using AI or machine learning or deep learning algorithms. And the important thing is here, it will help us also to qualify the simulation models. You might mention already the simulation predict very well the reality, but for this, we need to know clearly the boundary conditions. We still have to make assumptions, and we have a lot of noise during the production process. So this is something which we have to implement upfront in a simulation to get more and more precise. So at the end, the combination of the digital world and the real world is the key. And that's why we are developing for the shop floor area a lot of solutions. Similar is in the digital area by combining here also later, if we have the real parts, the prototypes, the inspection and so on, learning from it. And important is we need to look to the quality in the same way in the simulation that we do it in the production. Only then we have the same understanding. We are looking for the same results, and we can also have a common view from the different team members. And at the moment, this is not the case, but we have to bring it together. So we are talking also about virtual inspection plans in the simulation area as we have the real inspection plans in the physical worlds. And we are using this in the same way with the same tools, with the same of looking to the results. And all of this is common that we have different products, we have different time steps in the life cycle, but we have to store the data somewhere. And here the cloud system are playing a bigger game. And if we are looking now to the two different worlds, they need to be connected. We have a lot of incremental optimization steps in the different life cycles, and we can only do this if we have connect this. And this must not come from one supplier. It will come from a lot of suppliers, because the best is connect the best technology to have the most outcoming of it. And the established enterprise system, they are at the moment they don't have the right infrastructure to fulfill this way of thinking. And even we have a lot of informations upfront. We don't have a clear automatization pyramid anymore. So this means we need to have a different layer in between where we can bring the experiments together, all the iteration steps and so on, and then even link it with the real production. So if something will happen, that we can make a root cause analysis, but also getting simulation embedded. Yeah, this is what I already said. So we need to connect this, and we are developing such a platform within Hexagon in all divisions. It's the same base, that at the end we can learn from each other and can connect the different stations and the different sources. The sources are very, very important. If we are not able to collect data, then we cannot store it. If we cannot store it, we cannot analyze it. If we cannot analyze it, we cannot transform it into information to drive a decision. That's why it's important to have Industrial 4.0 ready devices. A lot of them still deliver analog signals, which then need to be transformed in digital formats. And a lot of companies, they are not aware about. They are thinking, oh, we can do the journey into Industrial 4.0, but they have a lot of old devices which cannot be connected, or if, then it's a high effort. So here we have to look that everything comes together, and that's why we can do it only stepwise. We cannot do it for everything. And at the end, you see here also a device. Simulation is also device. If the data are coming from a physical device or from a virtual device, it's exactly the same. A deviation is a deviation. A geometry is a geometry. And even if we are looking inside for residual stresses or so on, we can measure them with CT scans or other things, or we can simulate it. And at the end, these are data which need to be stored, which need to be analyzed. And if we are thinking about machine learning, deep learning, artificial intelligence, this should be always be based on a combination of virtual data and physical data, because in physical data, we also have the whole noise and uncertainties from the real process. And at the end, the target is that we are developing simplified models which will help us easier to give alert function, to drive decisions. And if this is, I would say, intelligent based on enough data, we can use it for autonomous systems. And these apps then can be implemented, and these apps can be used then in the design process, in the engineering process, in the production process, to adjust even the products. And the key here is also that at the end, the information we need to be put in a way in dashboards, on a mobile phone, on an iPad, that we can address it to different personas, so that they are really getting the information what they need in an easy way to drive a decision. And this is for everything the same, if it's a simulation or the physical world. And I will give you some examples for this. And design and engineering, this is the simulation area. You already have heard this in the previous discussion. The key is less prototypes, physical prototypes, and at the end, it's much, much faster. And the importance is that in the early stage where we are using the simulation, with the design, we are fixing the production costs later. So here we have all the freedoms. So it's better to invest in an early stage more money to be sure that the design is manufacturable and that the process at the end is robust. And it's not only producing the part, it's also assembly of the part, because we have at the end to look for the whole structure. And I want to give you some real case, because this is COVID-19. So what we have done here for the government in Belgium is that we have made some simulation studies for the COVID-19. What is the impact by using a mask or an elbow or without the mask? So these are simulations where you can see that wearing a mask when there's no wind and so on will secure somebody else who keep a defined or minimum distance. And at the end, without the mask, it's a high risk. And I think this is something we have to put in the brain from all the people, the Querdenker in Germany, who are still going on the street and saying it's not a risk and everything is easy. The simulation shows still, even with the elbow, you need a much bigger distance at the end. Now, here is an example. If you wear a mask and you have wind from 1 meter per second, and he's not protected with a mask, he directly get all of the aerosols. And so this is something where simulation can only predict the right behavior if we know the boundary condition. This is nice without wind, and then we can minimize the distance. Here we see, oh, if there's a wind outside, it may still make sense that everybody wear a mask to be protected. And here are other examples. Oops. I hope this will work. So this is a simulation where we are looking how secure you are if you are wearing a mask and also a visor. And you will see that only a little bit will go under this. So it's not 100% secure, but it's a little bit more secure. If both are wearing a mask here, yeah, even when he is lying and he's staying here in the hospital, it's a must that both wear a mask. If not, they are not secure. And this is another example here also. And this shows a little bit where simulation is. If you know the physical effects, if you have the right algorithms, then you can predict a lot. And even here, we continuously need to make physical tests to improve the models. And the objective at the end here was really to get a better understanding what happens in reality. Here is the case when somebody is standing in the train, and there you cannot keep the distance from 1 meter 50, so it's only 70 centimeters. We are simulating the airflow in the train, and here you see when he's talking without a mask, yeah, within 180 seconds, if he has COVID, he also will have it. So this shows a little bit how important it is to wear a mask. Even here you see that small parts of the aerosol can be are reaching the sitting man here or woman, but it's more safe. So at the end, simulation can help to accelerate building knowledge and drive the right decisions. The right decisions here, is a mask important? What is with the distance, and what is in trains or outside when there's wind and so on. And at the end, it also will help us for the direction for further investigations. What we can do if we are thinking about climate installations and so on, we can study this based on virtual experiences where we can play a lot with boundary conditions to make the right decisions. And at the end, also simulation will help the people, convince the people which decision is the right one. If you are in the design process or in the manufacturing process, often you have several ideas, but what is the right one? So simulation is also used to bring facts on the table and to make a decision based on this, so that at the end we can get the right decision and a robust process out of it. Now, if we are going further, a little bit away from the simulation of the design manufacturing process, we are also simulating, I would say, what is the best and easiest way to machine a part, to create the right NC program, and to make even this robust. And at the end, we still will have deviations. So we need measurements, and then we can reflect this back and correct the NC code. And what this shown here is that they are coming more and more together. So you are optimizing upfront your NC machine program. Then you have all the measurements from the machine, the status, the monitoring, and so on. And in combination with the quality, then you see the deviation, and then you can change automatically and adjust in a closed feedback loop the NC program. And at the end, you have to know what are influencing the outcome of the result. And even the measurement equipment, the metrology, will go out of the tolerances. So we have to control this as well. It's not only the behavior in the production. There are a lot of impacts, or if you are updating a firmware or whatever. So this means we have to have full traceability and traceability of the process to understand when something happens, where it's coming from, to make the right decision. And I think this is where you are aware of. So we have a lot of different metrologies in our portfolio, which we are connecting. There are also other players out, but the key is to bring this together. And regarding metrology, it's also, we need not only to monitor the data, we need to analyze the data. And we have to do it in real time and over a long period in the production to understand what's going on there and to detect anomalies or whatever. So here it means we need a lot of statistical analysis or later AI and so on to visualize the right information to give alert function and to drive decisions. And if this is a robust process, then we can automate it and feed it back to change some process parameter when we know what we can change. And here also simulation will help. Now another topic was the digital transformation of operations. This means if we are looking to the manufacturing plants, we have low visibility, no traceability, low adherence to processes, and often it needs a manual input. So this means we have to offer here solutions to digitalize all information stored in a common place, visualize it, and also drive decisions, and that everybody will have access to the right information and not using his own book where he makes some notes for himself. This is to give full traceability of the process. And here is a lot of things still to do. So it's not enough only to look into the virtual workflows. We also have to look into the production process to really get it and drive the process. And these are the things where Hexagon is focusing on. And important is also in the manufacturing process, you have a lot of different personas and you have to talk to the different personas in a different way. So this means you need configurable workflows, dashboards, and so on for the right personas. And at the end, also for the management to keep an overview in the plant or across the world for the different plants. This can only be possible if we have a common framework here, if we can bring the data where we need the data. Collaborative engineering systems. We heard a lot about digital thread, and digital thread is not only in the virtual world, it's also bringing pieces out of the physical worlds together here to get more accurate results outcoming of the simulations and so on. And we are talking here about collaborative engineering systems. So what this means at the end, we are combining the knowledge from the simulation, we are driving the workflows, do the different steps. And when we have informations from prototyping or the early production phase, then we are feeding back the information, we are storing it in the same environment, we are overloading the data, and we are looking to the data in the same way virtually and in reality, so that we can optimize the process, that we can make the right corrective actions. And this we can do at every step. And here we have to bring the metrology information into the right information, also to overload it with the simulation. And a quick example is shown here, body in white. So at the end, when the design is fixed, you have to assemble the part. The part are first sheet formed, where we get some deviation, and then with the assembly process, we define the final structure. And what we are doing here, that we are optimizing the information. And when we have the real parts, we can also use the real part for the assembly simulation process, which is much more accurate, especially in a spot welding area, and always combine it. And if something happens in the production and it goes out of the tolerance, then we can go back to the simulation model to get a hint to do it. And I think the right picture is the right one. What we need to do is really to connect the different steps the information. And if we have more accurate boundary condition to drive any simulation, we should do it. And simulation, you heard this a lot, is a key because it's cheap. We can automate it and then it can run in the background, and we only need to extract the right information very, very fast to give access to it and overload it with the information we get out of the process. So if we want to summarize it, this at the end is what we are doing. It's a continuous learning and improvement step. And we need to overload all the information. We need to store it. We need to use analytics and so on. And if we are thinking about AI, AI is nothing which falls from the heaven. AI can be only used if we have enough data. So we have to go through a period where we first collect the data, and better is to collect more because we don't know who is driving the process. So then later we can use AI or better machine learning because it's much, much faster than to create simplified models to drive the decisions and to feed it back. So it's a closed circle. And this is an example from a cell, which I already mentioned. So if we see that the outcoming quality, the measurements are going out of the tolerance, or there are some trends, then we can use this information automatically to correct the NC program that at the end, the quality is much, much better. And this happens without user interaction. These are algorithms which we have to develop. And we cannot do it alone, and it takes time. It's always working with partners, with the different ecosystems and so on. But the key is really bring the informations together. And what this means, we need the right skill sets also for the people. We need to bring the experts together with generalists. And nowadays, we need more and more generalists who really understanding the different disciplines, who are able to bring all these pieces together, because everybody is living in his environment. And we hope that we can contribute part for this journey for fully integrated solutions, constantly improve product quality, enhance productivity. And at the end, we want to have a real-time unified ecosystem. And if we make now the link to COVID-19, COVID-19 has accelerated the awareness that they have to do this much, much faster and stepwise, and they have to do it now. But still, the people need to be educated. And I hope I have shown you a little bit how important it is to bring the real world and the digital world together, that nobody can live alone. They are connected, and we never can control everything. We will still have a learning phase, but this is a challenge what we have. And thank you very much for your attention, and stay healthy.
Fantastic. Thank you so much, Hendrik. A really fascinating presentation again there, especially covering so many different angles of this coupling of the virtual world, and I'll say the physical world rather than the real world, because it always makes me feel that the simulation guys aren't living in the real world. So maybe that's just me. And also I thought, yeah, really good that, you know, you talked about how simulation has to inform the decision making, and I liked your point about referring to the different personas and maybe how you have to communicate differently the digital data to those different personas. And I think there's been a little conversation on the chat going that sort of emphasizes that point, really about you know, how we can utilize simulation for decision making, and it's about communication, where Teresa commented that the simulation really emphasizes the point about wearing a mask, and we should be sharing that more widely, but equally how that could be open to interpretation. So yeah, the debate rumbles on about the importance of communication and all of that. So yeah, thank you once again. Any other questions for Hendrik? Yeah, Rob,
maybe I can make one comment to your, because communication is the
of course.
And what is the biggest problem of the digital transformation is the organizational structure of the companies.
Absolutely, yeah.
Prepare for this. So if you want to go this way, you have to restructure, you have to build other teams. And this is, I think, also what everybody feel, that nowadays with COVID-19, we are thinking more in a matrix organization. We are talking more to each other. We are talking because we have time. Yeah, we don't do.
We have to break down those silos.
Yeah, but this is if a company say we want to go there, they are not ready to change the structure, then they will fail. And even what we are realizing in the past, ID controlled this process, but not now anymore. Yeah, the decision should others have to do. They need to provide the infrastructure, but that's it, not controlling the process.
Yeah, just a facilitator to it. Yeah, absolutely. Rob, go ahead.
Yeah, so it's more an observation or just playing devil's advocate a little bit, really, because a lot of this I'm supportive of, but I kind of see the problems or the roadblocks. One of them that this is all software underpinned effectively, so you're suddenly having hardware that is controlled by software, which suddenly means that from a purchasing point of view, you're not just looking at, right, we're going to buy this hardware and we're going to finance it or spread the cost over 4 years. You're also suddenly having to buy software to run it, and if that software changes or a version change means that, oh, you've suddenly bricked all your old hardware, like a Sonos I've got over there, can't upgrade the software on it anymore because it's out of whack. And those concerns start coming in for a business where you buy the hardware and then you've also got to buy the software to be able to use it, and you don't know how that software price is going to go up over the years, because despite not having much inflation over the years, software prices always seem to justify going up 5 or 10% every single year, which is crazy, really. So that's one thing. The other thing is that, like Hendrik said about companies needing to reorganize their structure and bring in new departments, you've got small startup companies that are kind of ripe for it because they haven't got the legacy issues, so they can dive straight in. But the cost of these systems and the PLM systems and so on is often really prohibitively expensive. Then you've got your really big companies that can do it when they redo a whole new factory line for a new car line or something, and they've got the money to be able to invest in the expensive new hardware and the expensive new software licenses, and they can buy thousands of licenses and get a big discount on them. Then you've got kind of the companies in the middle that have got the legacy problems but don't necessarily have the funds to be able to justify redoing a whole warehouse or factory, and they can't. They're kind of stuck in a really hard spot. And for me, one of the other concerns is the retraining of everyone on cybersecurity. Suddenly becomes really, really important, and the worry that if there's a problem with the controlling software, you might lose access to everything, really. I mean, we've seen it before where a problem with one bit of software that's kind of the hub of everything, and everything else stops because it's all trying to communicate with that. So you start getting single points of failure that no one understood before.
Yeah, good points. I think, as you say, the reliance on digital is going to come with some challenges that maybe those digital providers need to look at, both technically and commercially. Maybe there's different commercial models that need to be adopted here to make this make this adoption more rapid and more sustainable. Okay, good stuff. I think we should move on to our next presentation, which is from the gentleman over at Wirth Research. So I'd like to introduce Tom Avery-Hickmott and Jared Blackford, who are presenting on behalf of Nick Wirth on the topic of using airflow to understand and control the spread of airborne viruses.
Thanks a lot, Paul.
Gents, over to you.
Couple of very interesting talks this morning, and I hope you don't mind, given what you've said about us indulging in the virtual world and showing some of the work that the Aero team at Wirth have been exploring, really, because I think, much like everybody else on the call, is that the COVID-19 pandemic has been a challenge for engineers as much as anything else. And we've all wanted to come to the same conclusion of some restoration of normality. So if you'll allow me to sound a bit like Chris Whitty, can we have the next slide, please, Jared? So we've been working on what's been christened the Open Air programme, and really with one of the difficulties of an airborne virus is trying to understand how that flow moves around, and we've already seen from Hendrik some great visualizations, and we ourselves have also been trying to utilize our current tools as well as expanding those further in a virus spreading sense to understand and help mitigate against the worst effects of coronavirus spreads. So we work with a number of partners on projects resolving flows in both indoor and outdoor situations, and using these similar tools in CFD, we can analyze and identify potential hotspots that are of particular danger to everyone that passes through that region, and then start to mitigate these, whether it's a short-term mitigation in terms of restricting access to an area, as well as long-term mitigation on that area through initially items such as changing HVAC settings, and secondly through an open air christened product that will hopefully remove the need to worry about these regions, and with the ultimate aim really of reducing the need for the 2-meter social distancing that we've all been so accustomed to over the past couple of years. So on the next slide, we have a little illustration really of the basic concept of why we're all so used to the 2 meters in terms of reducing the risk based on the increased volume of air around each person as a 2-meter distance. We've seen that there's the spread both through the droplets, but also more dangerously the much smaller aerosols, which can linger in the air for a lot longer. And the 2-meter distance is particularly useful for that sort of flow to really reduce the risk for each person. So yeah, as I'm speaking, as we're all speaking, there's an elevated risk of droplets being spread all the way up to singing and shouting in football stadia, which I know has been something of a sore topic for many sports fans over the summer. So next slide, please, Jared. So whilst we're aware of the 2-meter distance, we're also very acutely aware that this is not a perfect solution, unfortunately. Whilst we'd all like to live in a perfect world, unfortunately we don't at the moment, and there are certain factors that can negatively impact the spread of the virus, particularly in unsafe wind directions, as the video at the bottom is showing, where the spread can actually be driven by wind directions outside, which can really exacerbate the spread and render the 2-meter social distancing rule somewhat redundant, unfortunately. There's also more complex structures as well as the straightforward wind assisted, such as vortex flow and rotated flows caused around doors and around corners of buildings. And it's those swirls and flows that we've got to be somewhat aware of as well. As we've seen through the number of studies that have been presented during the coming months. There has been a lot of evidence accrued in terms of how people have been infected, and also the way in which that has spread. We've seen people infected over larger distances than 2 meters, unfortunately, as well as the fact that it's time exposure and length of, some separation between the infected person being removed from an area and people arriving afterwards and being infected. So we've seen that, and there's an example that we'll see in a couple of slides time that will illustrate this further. We've seen articles. I think Altair's ran an excellent article illustrating some of these effects quite well. The spread itself has also been exacerbated by environmental factors. We're all aware that as it got cold, we entered the second wave, and temperature and humidity have both been linked to the spread. And this isn't only obvious in terms of greater climatic conditions as we move into autumn, but also we've seen around various locations quite intense environments such as food processing and the sandwich factories, that we've seen large outbreaks due to the controlled environment, linking the humidity, which makes it significantly more difficult to control how the virus is dispersed, as well as the fact that these people are spending a lot of time in these environments. And I'll pass over to Jared for a little bit more detail on some of this.
So it's been very apparent in some of the cases that have been studied in detail that the movement of air in a confined space has really increased the range at which COVID can spread from one person to another. So one example that was looked at was a bus in Hunan province. This diagram here shows this red person here was named patient A. They were infected with COVID when they got on the bus, and by the time they got off the bus, they had the infection had spread to all of these people marked in orange. The furthest of which was sat 4.5 meters away from the original case, and this is purely because of the confined space and the airflow from the air conditioning inside the bus. So that's something that we've been looking at, is how can we manage that airflow to try and reduce that spreading range, because clearly in the wrong airflow 2 meters to sit between people just isn't far enough. It's also interesting to see the person highlighted in pink was infected 30 minutes after the initial carrier got off the bus, 30 minutes before they then got on the bus. So the infection clearly has the ability to linger for a long time. So this has prompted the start of our open air project. The idea behind this is to look at how long it takes air from a certain location to be dispersed, to cycle through with fresh air, and so any potential contaminated droplets would be removed from that area, and then from this be able to kind of form detailed maps about where there would potentially be areas where people are more prone to infection, as air from different areas is concentrated there. And then we'd start to look at how we can change the behaviors of people in the confined space. Is it possible to move people away from those areas where risk of infection is higher? Is it possible to kind of just close them off, or just to prevent people from being in that high risk area? And then as the next step is a more detailed look at the airflows and how we can alter those to kind of completely eliminate these areas, to remove the need for these kind of blocked off areas that would be that would otherwise have to be in place. So one of the examples we've looked at is in supermarkets. We do a lot of work with supermarkets. And so it's a natural place to start because there are a lot of people there. So this image, you can see the airflow through the shop, and in this red area here, you can see air from all of these aisles and from this door over here, passing over the tills, over these checkouts. So the people who sit at these checkouts are very vulnerable to infection because they spend a lot of time sat there, and they air is brought to them from all over the store. So this would be a very high risk area, and would be somewhere we'd look to avoid having people spending long periods of time to help reduce the spreading risk. John.
So I think the supermarket one is particularly pertinent given the number of times we've all had to visit the supermarket and not much else. And there are people that have had to work through this pandemic, so minimising risk for those that have to expose themselves, I think, in want of a better word, to a greater or lesser degree to the virus is certainly quite important to us. So really the two main effects that we've seen that can help mitigate the worst of the airflow is a downdraft, so the flow moves to the door, moves to the floor even. So it can effectively allow people to move closer without the risk of being directly impacted by viral spread, as well as the dilution through additional fresh air that's being provided to a region. We're all acutely aware that, especially in winter again, as we move back to it, fresh airflow is not always available or comfortable at in this season. So we've also worked within trying to recreate some of this downdraft and dilution effects for enclosed spaces that can't really achieve this. The first of which is shown on the next slide. So we're all very aware that we've been missing from office spaces, and certainly I think some of the images of first lockdown where we saw a ghost-like city of London, which is usually the hustle and bustle, and many incredibly tall skyscrapers stood completely empty, and the difficulties with then subsequently getting people back into these offices. Not everyone's going to be able to climb 30 flights of stairs to reach their floor, and lifts are particularly one area that's very vulnerable. So we've looked at creating a vertical flow inside lifts. So there's a vertical downdraft that is driven through, and as the air is recirculated, we want it to pass through a region of quite high heat, as we've seen that heat has been very effective in killing off the virus, along with other measures such as high intensity UV. But yeah, passing it through heat can freshen the air and reduce the potential impact of the spread. So I think on the next slide, we've got a slightly further developed video of this, showing how the current situation, even with social distancing, is that people, we recognise this is the worst possible case for people facing each other, but there's still the potential of spread in these enclosed spaces. And introducing the downdraft can be quite effective in acting against this. So this is slightly sped up because to show the downdraft more effectively, but we can see that at 1.5 meters in these enclosed spaces, we've been able to reduce the horizontal spread of the virus, mainly in favor of a downward direction, which will then pass through the circulation zones, including the autoclaving system at a much higher temperature. So this will allow increased capacity. So we've heard about the impracticality of everyone having to go in a lift one at a time. So this is really something that we've looked at and we believe could help allow for some restoration of capacity, which, as the last set shows, that even a mask can't completely remove. So both mask use and the open air vertical flow could therefore be combined to have some great effects in that sense.
So the process we've looked at for the destruction of the virus is called a continuous autoclaving system. This process relies on heating the virus very quickly to 95 degrees C or higher, which destroys it. And so part of the process with the lifts model is drawing the virus through a heated section and then cooling it down again before forcing it back into the lift. The way we've looked at doing that is to have pipes with ambient air and pipes with heated air running next to each other to allow for heat transfer between those channels, just to reduce the heating and cooling requirements needed. And this this is the solution we are looking at to help control this virus. This particular example would be applied to the air handling system in a supermarket or other large building. And we've also looked at installing this into the lift. So here's a brief video showing how the air travels down through the lift. It's drawn up through the grate at the bottom, and it travels up to the top where it's heated to destroy the virus, and then is recirculated back round to travel back through the lift. So this is the solution we've been working on. And as you can see from this side-on video, the air travels back through pipes that run parallel to each other to allow that heat transfer to reduce the energy requirements. You can see these are all very thin pipes to allow for maximum possible conduction between the hot and cold air supplies. Another thing, we've looked at solutions that could be applied to other areas as well. So where there are places that the air can be vented outside, we've looked at methods for just drawing that away and drawing air downwards and away, removing it from the building. So this is a kind of mesh flooring that people could stand on, and it would draw air down through it. Again, providing that vertical airflow to help prevent transmission. And here is a quick image of how that would look. So again, this would be targeted at areas where where queues form, where people are unable to maintain 2 meters distance practically, and this would allow people to be able to stand much closer together without risk of transmission. And these ducts standing on these ducts would induce that vertical airflow, and then the contaminated air would be drawn and vented outside. And we can see how this would work on board something like an aircraft with people crammed in very close together, but with a vertically induced airflow, it would minimize any risk of transmission. And again, this would simply require venting at floor level to draw air down, and the supply of air from the ceiling. So this, and you can see this, there's no transmission here from one row of seats to another, so it vastly minimizes the distance that the risk that any passengers face if one of the other passengers is infected.
And I think whilst we're very acutely aware of planes being full and willfully travelling with coronavirus is probably not what we're looking for at the moment. I think certainly when we've seen asymptomatic spread something like this is something that could, we feel, be beneficial in restricting these super spreader events, which have statistically shown to be a key driver of the whole pandemic, really. And that's really part of what we want to mitigate for. So in summary, what we've tried to do throughout the open air process is visualize something that we can't usually see. So the airflows of the air and also particles suspended in it, and try and find the best ways of identifying key problem areas and areas that might be subject to high viral load or explicit risk, such as in queuing areas that we saw with vertical transmission, with vertical airflow to reduce transmission, and it's about protecting us all in the same way that we all wear a mask. And this is, like we see, it's in shops, it's in offices, warehouses, meat packing centres, and this is something that we feel that visualising the flow, using simulation, is something that can really benefit both understanding and also communication in getting people on side and following the key messages that we've all seen during the pandemic. So with that, I will conclude our presentation. And if you have any questions, please feel free to ask us.
Fantastic. Thank you, Tom. Thank you, Jared. And I think, yet again, another very powerful presentation showing just the great power of simulation and communication, visualization, however you want to pitch it, which has been echoed through the entire theme of the presentations today. I guess it also segues very nicely into the roundtable discussion that we've got lined up, which is all about the future of work and what the workplace might look like. So you've already provided some fantastic insight into that. And maybe in the interests of time, I'm very conscious that some of you may have hard stops at the end of our agenda session. So maybe we can sort of open up that into this roundtable discussion, and perhaps any questions that may be had by the audience for Tom and Jared will come out during that discussion if everyone's happy to progress with that. So to that end, perhaps I can also welcome Amy, James, Sophie and Ashley from EMW, as well as Ian from Hoare Lea. I'm trying to see who else we've got on the line there. I hope I've not missed anyone. But yes, please, let's open this up to a roundtable discussion all around this the future workplace.
Good morning. What I'll do is I'll just go along our little panelists and just ask them each to just introduce themselves and give some context so that you know kind of where they're from and what they're about. I think it'll be useful. If we just start with Ashley, would you like to just hop on?
Yeah. Hi there. I'm Ashley Bateson from Hoare Lea. So I'm a consulting engineer and head of sustainability. So I was really interested in those ventilation diagrams actually. So yeah, I do a lot of building design. Thanks.
Ian?
Yeah, morning. Yeah, interesting to see some of the impacts on offices and tall buildings and lifts and things. I'm a director with Bray Fox Smith, working with landlords and occupiers as a commercial property consultant. So certainly the office sector is going through potentially a profound change, and obviously we're all wondering what 2021 is going to bring us. So thank you.
Something better, I hope. That's what we're hoping.
Absolutely. Absolutely.
Priya?
Hi, morning everyone. So I'm Priya Mega. I am an associate in the employment team at EMW. With everything that has changed this year, workplaces are incredibly different. So kind of I'm going to be touching upon probably the considerations you need to consider from an employment front.
Thanks. James?
Morning, everyone. I'm James Davis. I'm a principal at EMW. I'm head of the property litigation team. So in months gone by, any problems that people have had with leases, their relationships with either landlords and tenants have come to me. So happy to answer any questions, and hopefully we'll get on to what people should do if they're having issues with their leases a bit later on. Thanks very much.
Thank you. And then I am Amy Barrable. I'm a principal in the real estate team. Naturally, I have been watching some of the property debates with interest over the course of the year, and it will certainly be interesting to see how things pan out in the future. So I know that there are probably questions that you guys have got, and I'm probably desperate to get some questions off your chest that you've been saving up from the previous session. I just wonder whether, if it's all right with everyone, we've kind of structured our little panel session into 2 segments, and then perhaps we can pick up some of the other ideas, which I think there will be some crossover in terms of what we talk about as we go along. So our segments are essentially split into changing ideas about the workplace and some challenges that they may pose. And then the second section is more about some of the practicalities in terms of if you are changing use of the way you use your building. So I think there will probably be some, definitely be some crossover. I hear that the way that you've been doing questions is to come off your, well, effectively bring your video on and come off mute. So I'll try and watch for you all coming off and hopefully, point in the right direction in a polite way with, reference to a nice jumper you've got on or something like that. But forgive me if I miss you, okay? So I don't think it came as a surprise to many that when we were faced with a pandemic, there were a lot of us that were actually able to make the switch and work from home. I think faced with the uncertainty over second spikes and things like that, a lot of businesses who could took the decision really early on in the year that they would actually have agile working policies that took us into next year, which I remember thinking at the time, come on, surely it'll all be back to normal and we'll be all right by then. But sure enough, here we are 2 weeks before Christmas, and still with an element of uncertainty there. So I think that those policies, they were probably right, good for them. I hope they put the lottery on as well, because they're probably quite lucky. Now, of course, agile working itself, it's not a new concept. It's just that Corona has brought it right to the fore in terms of the debate. There's a whole host of issues, obviously, in relation to agile working. We can't really cover everything today, but there are a few things to think about, like the impact, obviously, of COVID on the workplace going forward, better use of technology, questions about culture and integration, and also generally a big debate about improving, space for their occupiers going forward to make people actually want to come into the office from time to time. So without further ado, I would like to hand over to Ashley and to ask specifically in relation to some of your research, Ashley, what have you found in terms of what people actually want from their workspace and their working life?
Yeah, thank you, Amy. So we do a lot of workplace satisfaction research and investigate what people like or don't like about their workplace, and we've also done research on how that compares with the home environment. I'd say there are 3 changing ideas at the workplace about health, about well-being, and about sustainability. On the health front, I think there'll be a lot of attention to air quality, and I think that this is part of a trend anyway. I think people are more interested in conditions in the workplace, access to data. We monitor air quality in all our offices, and we have an app and give some people access to the data, and they're more interested in that metric than any other measurement in the offices, air quality. So there's that health aspect. The well-being aspect, I think, is about culture, about agility, flexibility, and again, I think COVID has just accelerated a trend that was going to happen anyway. People want a variety of methods of working. So work is something you do, not a place you go to. And can you do some of that in the office, some of it at home? I think we'll find that is a change. And then the third theme is sustainability. So I think it's interesting that in the economic conditions compared to previous recessions where people have declined their interest in the environment, I actually think that people's interest in climate and the environment has increased. We're getting more property queries about the net zero carbon agenda and sustainable design. So that's an overview of what our research shows will be changing in the workplace.
Thanks, Ashley. Obviously, if we are going to make changes in people's working environment, then there are some potential challenges that could come from that. And I think, could I just bring Priya in? Because I imagine that you've had quite a few people seeking your advice in terms of employment issues that have arisen as a result of the fact that people have needed to work from home, or perhaps the opposite in terms of when they've been asked to come in and perhaps haven't necessarily been that comfortable to do so. What have you been finding in terms of challenges?
I mean, I think it's clear, Amy, that the Monday to Friday 9 to 5 employers requiring their employees to be in the office is no longer really going to be happening. But then on the flip side, yes, while agile working has always been in place, I don't think it's been to the extent that we've had to deal with now. So, I mean, in terms of the issues that I've seen clients be faced with is, firstly, and this was before the second lockdown came in, when the restrictions were easing and employers were wanting their employees to come back into the office, there was obviously some reluctance on some of their employees because of health reasons. Now, whilst that is perfectly understandable, I think from what we've been advising employers, if they haven't done so, you need to do a health and safety risk assessment in terms of the property that you have in place, the COVID measures you've got in place, what procedures you're going to be putting in. And, it's all about dialogue with employees in terms of the reluctance to come in. And I think what we've been advising employees in the first instance is to do that health and safety risk assessment and then talk with their employees. And if there is a real reluctance, to see whether there's any flexibility. In terms of practicalities with agile working, quite a lot of issues we're starting to find is things in relation to, say, supervision and training, performance management. When this, me included, when this pandemic first started, we're like, oh, it's only for a few months, be absolutely fine. We'll get back to normal. And so from a performance management perspective, things have gone on a bit of a back burner because companies don't have necessarily procedures in place, to supervise their employees and effectively train them. And I think what we've been saying to employers at the moment is you really need to start looking at your performance management processes. If agile working is something you're willing to have and are perfectly, acceptable for moving forward, you need to make sure you have procedures in place to effectively manage your employees, have targets which are ones that you could actually monitor if they are working from home. And a lot of it is communication. I think quite a lot of companies need to, in a nutshell, increase their communication a lot more with their employees if they're looking to do agile working. That doesn't just work from a supervision and training perspective, but also from employee engagement. We've got quite a number of employees feeling isolated as part of working from home because they would rather have the team environment, would like working with people, having the social aspect of it. And so I think at the moment, while we're still in this, coming out of a lockdown, but unlikely to be going out of the, you should work from home unless you absolutely can't. I think employers really need to start looking now at what procedures they've got in place and how they may need to change to deal with this world of agile working.
Thanks for that. Yeah, I think there is a bit of a challenge there, isn't there, in terms of making the workplace suitable for kind of all purposes. And I think for some people that might just seem oh, there are too many things to think about. Can we just get back to normal? But I think it would be a missed opportunity if we didn't really look to assess how we can do things differently and make a difference as a result of such a rubbish event having occurred. I mean, does anyone want to share how they found their sort of home working versus desire to get back in the office experience?
Okay, the experience is I miss the old time. If you are traveling worldwide and then you have to stay at home, I would say over a long time it will disturb my brain. But I want to bring up another topic. What I realized is that if you know the people, it's easier with a home office and they don't feel isolated because you know already each other, and then you can go on with the communication, or you do a different kind of communication. But if somebody starts and he have never met anybody, it's extremely difficult. And this, I think, is very, very dangerous for the future, because we already need a mix. We cannot say either or. We need to keep a personal communication, and even if we want to develop something, we need a whiteboard. And I think at the moment, my feeling is, or experience, with all the team meetings, it's maybe 10 times longer. It's a hard iteration step. Yeah? Instead of sitting a half a day together, yeah, you do it over months. And I hope really that next year it will change dramatically again, and that we are allowed to go to UK.
I think that's probably right. The mix. I think everyone that I've spoken to has missed the collaboration, the social aspect to things. Certainly, new starters within our own business, they found it very difficult to sort of integrate themselves in the usual way. I mean, we've had so many Zoom coffee mornings and social events and things like that, but I suspect there's no real substitute for actually interacting and collaborating over the job itself. So I think from a personal perspective, I'm very much of the view of we will need some sort of mixture between sort of homeworking that allows us to focus on things, but also the ability to come in and particularly in a sort of office environment, not just to come in and sit by ourselves, but very much to collaborate with each other, and for the office time to be the noisy time, the collaboration time, and where you're not necessarily expected to sit and work in a way that you might have done previously, which I think is I think a mixture is probably the way forward. And obviously in the back of all of that is the way that we prepare our buildings to actually accommodate that collaboration is also very relevant. So we work in open plan, we have done for years, and I remember coming across at first thinking, oh my gosh, your senses are kind of overloaded by everyone talking about things, etc., etc. But actually the amount of information that you pick up almost by osmosis, if you like, is incredible. And just the little meetings where you can just say to somebody, lean across the desk and say to somebody, what do you think about this? Which in a virtual sense, yes, we've got all the technology in terms of being able to ring people, Zoom calls, all that kind of thing, but it almost feels like more of an imposition to call someone or to set up a meeting than it would be to just kind of pass them in the office. So I think the space that we need will be very different to the space that we currently have, because having all your individual desks with your individual setup with your photo, your photos out, I think that's probably really getting to be outdated now.
Yeah, if I may come in on that, I think it's really interesting, and I think it's going to be really complicated as well, because one of the concerns that I have, so Jared and Thomas did a great job of sort of showcasing systems that would allow sort of rooms to and groups of people to be closer together, and so to encourage that collaborative working and all that sort of stuff. But if you as a company want to implement that, because surely there's especially with workshops and factories and all that sort of stuff, you need to have people in close physical approximation to enable the job to be done. But those systems aren't going to be free. Presumably Thomas, Jared, and Rob and the people at Wirth aren't generous enough to provide all of that free of charge. And so you're kind of faced with that additional cost for this working together at the workplace. but you're probably also faced with additional costs to enable people to work from home in terms of providing facilities and kit and all that sort of stuff. And maybe, you know, your training needs increase, you know, if you're not able to bring people together and all that sort of stuff. So one of the concerns that I have with that, because I do agree that we'll end up with sort of a mixed culture, but it seems like there's going to be quite a lot of additional expense that the companies need to bear, and it's kind of difficult to see how they would be able to reclaim that. And I would love to get the panel's views or you know, anybody's views on how companies do that, because surely you're looking at, you know, quite an increase in expense potentially, and how do you cope with that?
Ashley?
Yeah, I think the benefit is improved productivity. So, and it's going to be a bit soft here, but I think there will be a payback in improved productivity if you invest in very good working conditions. So there is evidence that if people enjoy the workplace, they're more productive. I mean, there's lots of studies showing that if they don't like the workplace, if it's bad daylight, bad air quality, there's a lot of research on air quality showing that if there's not enough air change, the carbon dioxide internally increases. And not only is that a proxy for it's stuffy and badly ventilated, carbon dioxide actually affects your cognitive functions, so you're less able to concentrate. So I think it needs a business to be open-minded about that investment. So if you are going to spend 50,000, 100,000 in changing the ventilation system, and then of course, is that the landlord's responsibility or the tenant's responsibility, that you will get a return on the investment later. Now, it's very hard to improve that you'll have £100,000 increase in productivity, but there is a lot of anecdotal evidence that you will get more from employees if you have a better work environment.
Ian, what are you finding in terms of people, you know, asking you for advice on the properties they should look at? You know, what is happening out there? Is everyone? I thought everyone would just literally be trying to get rid of space because they were thinking it's fine, everyone's working from home. We just want to get rid of as much space as possible because that will save us money. But you know, as Pim pointed out, some of these things that will improve the workplace will actually require investment. I just wonder whether everyone has the luxury of being able to, you know, consider that long-term view, or, you know, what are they going for first?
Yeah, just to answer Pim's point, obviously, depending on how your occupation is structured, how your lease is structured, that investment may well sit with your landlord. And actually, it is something which, going forward, freeholders of the properties, the pension funds, the property owners have got to look at this, because they've got to make their properties more appealing to the end user, as much as you as business leaders have got to make it appealing to the staff. So the return to work risk assessment sits as much with the freehold ownership as it does with the occupiers of the space. There'll be slightly different dynamics, but and some of that cost will potentially sit with the landlord. So, for example, I was with some occupier clients last week. We're doing some estate strategy work, part of which has been driven by COVID, part of which is driven by day-to-day business. And I sat with the client in the meeting. We talked about the lease renewal, which is mid next year. I said, that's great, but yeah, what about your space? Is it fit for purpose? When you took it on, you were a business that was then acquired by a bigger firm. Does it now reflect the ethos of your business? Does it do what it needs to do? But frankly, one of the most important questions, given the age of the building, is the air intake and sort of cooling systems which are sitting above our heads. That requires investment. So that requires a conversation with the landlord, not just about structuring a new lease and the right terms, but actually about how can it work for both parties, because they have to future-proof their investments. And let's be honest, all of us sitting here now are impacted by whether the death of the office is a reality or not, as the case may be, because the pension funds and the investors, our pensions are all, you know, there's a lot of this stock sitting in there. So if we drive the value down, ultimately it will impact on us elsewhere. Now, that's not to say that we've got to get back to the office, but I think there's a balance to be had. And I think, yes, there will be some financial implications, but actually, we've gone through these peaks and troughs previously where, something has come along which has caused a significant impact on the property market. And ultimately we adapt and we find a way around that. And I think, as people have said, the flexible regime was coming in, the ability to blur the division between the workplace and the home life by making the workplace more appealing. And let's be honest, our occupational efficiencies, generally, we don't use our desks much more than 50% of any given week. So actually there's plenty of flex within what we have to adapt and change that space. Doesn't mean we have to throw it all away and go and relocate somewhere else. Or flight to quality is a phrase which is talked about because people want something which provides that recruitment and retention of talent, so it reflects the business. But ultimately, you can refresh what you've got, and you can work with your landlord, particularly if you have lease activities or an opportunity. So that value piece, it's an opportunity for the tenants, but it's also an opportunity for landlords. And I think Ashley referred to the carbon zero. I think there's another trigger in 2023 around EPC ratings, which will impact on the built stock. So actually, we've got to look at this as a watershed moment, and particularly in and around where we are, the Silverstone Technology Cluster, Milton Keynes. There's a lot of aged stock, which frankly isn't fit for purpose. So the challenge is to get people back to some of those buildings, and actually then how can they be adapted to provide safe working environments and better quality working environments for the people that occupy them. Sorry, that was probably a long-winded answer, but
no, that's good. That's good. It's covered a lot. I think probably just on the back of that question, actually, Ian, can I just ask Thomas? Obviously, you were talking about various pieces of equipment that could be installed in order to improve airflow and that sort of thing. Are all of those things expensive and or easy to fit? Because I'm just looking at it from the perspective of, something that Ian touched on in terms of landlords and tenants needing to work together if alterations are needed. It'd be good just to get a view on that, if you would, please.
I think at this present moment, and Rob, please feel free to strangle me if I'm starting to speak out of place, but a lot of this is done in virtual sensors. So we've created something, but we've not yet had the chance to size up the restrictions, contractor issues in terms of the practicalities of installing items, the sourcing of parts, whatever. So we haven't really completely costed up something yet, which probably makes it a little bit more difficult and probably not the answer you're looking for.
No, I'm totally on the spot.
I think there'd be a big variation as well. So some of the examples with the continuous autoclaving, they would be more expensive, but where you can just blow the air out of the building, then it's effectively standard HVAC type pricing. It's just a new way of thinking about the way you lay it out. So traditional HVAC design's kind of about calculating how many air changes you need and not really worrying so much about what direction that air's blowing. So it's about taking existing hardware to another level in terms of how you plumb it in. So it shouldn't be massively more expensive.
And I think as well is that it's been mentioned about the climate considerations that up until the pandemic have been quite important, is that studying the airflow to use it more efficiently, and Ashley's considerations in terms of carbon dioxide levels, it can be one way you're kind of not just improving the work environment, but you can also be having a positive climate effect with some of this as well.
On the office use question and getting back to working in the office, something that us at Wirth Research we're going through at the moment, a number of things have come along at the same time that means that our lease on our current offices are expiring soon. We're due to renew all our HPC, and we've got a whole data center in the heart of our office building that's kind of anchored us to that site for many years. And we're now going to be replacing all of our HPC and data center, but host it remotely in Iceland, where it's all renewable energy. The latest computer hardware is giving us about a 75% energy saving anyway. Then the costs of it being in Iceland is saving us even more money, and that's meant that we've freed up the way we need to use our building, which means that we can shut our office down, which we've done anyway with everyone working from home, and then we're able to take on a short-term lease on much smaller office space to get us through 2021 and have hot desking where applicable. And then I'm hopeful that we'll kind of transition into having a bigger office again, but on a more flexible basis than previous. So I personally want to get back into the office. I think we're less productive working from home. We've taken on a lot of new starters recently, and the training up of them has been difficult, and kind of getting them into kind of the Wirth culture, because as people feel they belong to a company, then they tend to be more productive and they stay longer. So it's all about that. But we're kind of fortunate at the moment where we've been able to let go of the existing and frankly really dated building we're in, let go of that, make massive energy savings as well and cost savings, and then transition to something a bit more flexible going forwards.
Thanks, Rob. I mean, it's interesting what you say about looking at more flexible arrangements, and I think that is one of the other discussions that is being had at the moment. Obviously, I spend a lot of my life doing landlord and tenant negotiations in terms of the lease documentation itself, and there is a degree of discussion about how they're sort of outdated, long, unnecessarily complicated, and all the rest of it. But for fear of doing myself out of a job, let's say, I do see that there is an opportunity there to actually almost reformulate the way we do some things in some instances where there might be an industry that allows that is more appropriate for there to be some sort of flexible arrangements, easy in, easy out. I'm going to throw this question to Ian as well. Actually, I don't know how much pressure there's been in terms of call for more flexible leases, shorter term things, while everyone's trying to get themselves sorted. And kind of, do you see from the negotiations that go on that there will be a push for people like me to draft shorter documents?
Well, certainly, in fact, I had a call this morning from somebody who was looking to downsize and said, well, can we take a 3-year lease with rolling breaks as well? Is that really what you want? Because obviously, you undermine the value you could achieve out of taking even a 3-year lease. And obviously, you've then got the fit out and everything else, which you have to account for over a period of time. So I think the reality is through 2020, there hasn't been enough transactional evidence to support that, because I think a lot of people are still dealing with how they get back to their current office, let alone taking on new leases, etc. So obviously we've seen a dip. I think I mentioned to you previously, Amy, that across the southeast we would generally see something like 3 million square feet of take up, and I think this year, including counting some sizable deals in Surrey, we're about 1.7 million, so a long way behind the figures. So that puts into context the impact on the office sector in 2020. I think there will be clearly flexibility is key, and there's been lots of talk about, is there a hub and spoke type approach, particularly around London and some of the sort of major cities where there's a lot of commuter traffic, and reducing the time that people spend in the core office, but creating more flexibility. Does that create a need for more touchdown space in serviced office environments? We've seen and innovation centres, we've seen those obviously grow and grow over the last sort of 5 years. Will they have their place, or are people afraid actually to go in and share space with a multitude of other businesses? For some people, it might be counterintuitive, but I think there's always going to be impact. Supply and demand will drive whether people can get short-term leases, and whether there is the right quality of stock in the market at any given time. But certainly, I think the question will be asked more frequently as we go into 2021. But I think one thing I would say is property costs generally are about 3 to 5% of a business operational costs, whereas staff costs can be anything 80, 85%. It's making sure that actually decisions around property, which are key, but actually engaging with the staff and making sure that they're with you on that journey, because ultimately it can have a greater impact on the business than perhaps entering into a 2-year, 1-year agreement on the wrong building. So I think that whole engagement with the staff is a key element to all of this.
Yeah, I think I agree. And I think, Ashley, you mentioned something when we were talking the other day about obviously millennials are becoming a greater part of today's workforce, and they have slightly different ideas on what a good workplace consists of.
Yeah, so we did a survey of 500 employees, and then we did some demographic comparisons, and we found that the younger generation, so under 30s, have higher expectations of the quality of the workplace. They want green plants, they want fresh fruit, they want nice coffee. There's a similar piece of research showing that as people work from home and they see green plants and have an openable window, that everyone starts to want that better workplace environment. So and with we were doing some work with a big accountancy firm. For them, the quality of the workplace was all about attracting and retaining talent. So you know, as just has been said, the labor cost in the service and manufacturing industry is so significant that anything you can do to get the most talented people and keep them there is good investment. So yeah, I think the expectations of the workplace from people you're trying to recruit has to be considered. And what it probably means is you need that stakeholder engagement in the new workplace design, because the older generation might be less appreciative. They under 30s and 35s want more flexible working, want breakout spaces where they can either eat at the workplace or have social contact, yeah, it will change. I think COVID is just accelerating this change that was going to happen anyway. It's just made us get there quicker.
Thank you. I'm just conscious of time, and I think we should move on to our second sort of aspect, which is about the practical considerations if you are thinking about changing your property and changing use of your property. I feel like I wouldn't be doing my lawyer's job properly unless I highlighted some of the risks that may be attached to just willy-nilly going ahead and doing some things with your property without letting somebody know. So, for example, you may have restrictions in your lease which prevent you from doing certain things or require that you need consent from your landlord. You might also, and you perhaps haven't thought about this, is there might be restrictions in any mortgage that you have if you are a freeholder. So obviously just be aware of those things. We've seen a lot of people pivot. Pivot has become another word of the year, hasn't it? So it's furlough, pivot, you know, all these things we never used before. Now all of a sudden they've come into common parlance, so to speak. So a lot of people have sought to pivot and do something different from the property that they occupy. I think probably to a degree, things that have required, these things would require consent, but the landlord's probably turned a little bit of a blind eye, provided that they're getting their rental income, and probably taking the view that it's better to have somebody in there doing something, as long as it's nothing, you know, nasty and untoward, than to have nobody in the property at all. You know, similarly, in terms of if you've needed to make some sort of alteration in order to facilitate the new thing that you're doing, again, I'm going to bring James in a sec. I can see he's chomping at the bit to get involved here. You know, if it's all right, I think the landlords have probably, as I say, been quite lenient with that. At the flip side, there's obviously a situation where some people have really struggled with the property that they have, and actually the property costs associated with that. I'm just going to bring James in here to comment a little bit on my my free and easy comment that landlords have been lenient in relation to breaches, and also just to kind of comment on the position with regard to, if you are struggling with some of your lease obligations.
Well, I wanted to contribute, Amy, to the views of the under 30s on their working environment, but I suspect those days have long gone, sadly. So I will have to stick to lease problems. I think Ian stressed this earlier, and it's the key point. The situation we're in at the moment is not one where it's just a problem for tenants, or it's just a problem for everyone. It's for every tenant who is struggling to pay their rent. We have a landlord struggling with their own banking covenants. So we've had this on all sides. The lease is a contractual obligation between both sides. And what's key is that any assistance given by the government, and the government's tried on this, has always been with the small print saying, actually, we can't do very much. And we really hope that the landlords and tenants are going to talk about things themselves and come to a sensible arrangement. So the government have put in place certain delays on enforcement action, for example, that's helpful. But ultimately, the obligations don't change. The obligations have always been the same. And all that's happening is the problem is shifting further down the line. So I suspect early next year, first few months for many, many people are going to be very difficult because the obligations are still there. Now, the key is just don't do nothing. If there are any problems under your lease, do something, speak to someone. And there is an obligation on the landlords and the tenants to have a responsible attitude and to discuss problems. Following on from that, if a landlord, for example, is prepared to offer concessions over time, get that documented in writing, get it somewhere so that someone can refer back to that. Really, the relationship now is changing. It's more flexible, but there will be landlords who don't want to negotiate. And we've had those as well. We've had the whole range of responses from landlords wanting their quarters rent on the given day, to others who are prepared to wait. The key is just keep talking, see what happens. We can't change obligations under the lease, but there are reasons why landlords will have to take a more reasonable view, and we've got to find the way to make that happen. But we haven't got a magic wand. I think in years to come, there will be different negotiations when lawyers come to discuss leases. There will be different views on how they should be phrased, but at the moment, we'll start with what we've got. And really, there's no way around that, I would say.
Thanks, James. I think what's coming through in all of this is that communication seems to be absolutely key, irrespective of what element you're looking at. So, right the way through from actually asking the employees what they want from their workplace, talking to your landlords about any potential consents or anything that you need in order to facilitate that, any potential issues you have in terms of compliance. And then I think just generally sort of keeping an open mind in terms of the discussion, because there are other elements to the whole debate on agile working. The sustainability debate obviously has taken a little bit of a backseat in terms of the agenda while we've been kind of busy dealing with a pandemic, but that will be right up there going forward. And I think we've got a brilliant time to reassess and reevaluate that we should definitely use to try and work out how to make things better going forward. But yeah, I mean, if I had a crystal ball, I could see sort of 10 years time. It'd be really interesting to see what things look like. I don't know if anyone else has any particular questions for anyone. Just try and look across. We're good. Good. I think that's probably bringing things nicely to a close, Pim.
Yes, thank you. I think so. Paul?
No, I agree. I think it's been a really fascinating session all morning. And I think, the general theme seems to be around, communication being key in all of this and helping resolve all sorts of issues and take opportunities. I think we've also seen that across every single domain we've discussed, COVID is accelerating these opportunities, and they should all be seen as opportunities. And it's how we react best to make the most of them. So no, thank you everyone. Thank you, Amy and the rest of the team there that have joined in that discussion. And likewise to the various presenters from this morning's sessions as well. And on behalf of the DSM, so yeah, thank you all, and yeah, back to you, Pim. Thank you.
Excellent. I second Paul's views. I think it's been really fascinating and really interesting. And many thanks to all the speakers, of course. Now, what I would like to do very quickly, it's not going to take very long, as we always do. I just want to run a poll very quickly to get your views on this particular event, but also on what you would like the DSM group to look at next. Because we're always aiming to have fascinating discussions like we've had today, and the more information we can get about the type of things that you want us to talk about, the more that enables us to do that in the future. So shouldn't take very long to complete that also, if you wouldn't mind doing that. So while everybody's having a go, I'd like to thank our audience on YouTube for watching. I hope you find it fascinating, and thank you very much. Obviously, do check out the STC event page for any future events coming up that might be of interest. And I'm also reminded that whenever I watch videos on YouTube, they always say, subscribe, like, and share and all that sort of stuff. So could you please do that here? Because apparently that's really beneficial. So thank you very much for watching, and hope to see you again soon.